Hello, and welcome to AC Circuit Fundamentals. Chapter 14 is on magnetic induction, and we're going to cover it in this video. Electromagnetic induction is certainly one of the most important concepts in our field, in the electrical field. It is the basic operating principle for alternators and transformers and AC motors, and we're going to be talking about those things over the span of the course, the semester. It's a basic law of electricity that whenever current flows through a conductor, a magnetic field is created around it. Also, whenever a conductor cuts through magnetic lines of flux, a voltage is induced into the conductor. We're going to go into these concepts deeper as we go through this video. So in this slide, we see that we have, so basically this is a conductor, think of it as a copper wire, and the arrows are indicating that current is flowing through the conductor. We're just going to take a quick second here and talk about what is current and also what is voltage. Let's start with voltage. Voltage is electromotive force, or I like to think of it as electrical pressure. It's basically it's a force that's pushing or trying to push electrons through a conductor. If you took DC fundamentals, then you should understand these concepts. When those electrons have a path to flow, then the voltage pushes electrons through the conductor. That movement of electrons through the conductor, that's current. So when current flows through this conductor, a magnetic field is created around the conductor itself. Now when current flows in one direction, let's say this is flowing out when we're going right to left, the magnetic field rotates in one direction. If the current is flowing in, let's say the current is now going from left to right, the magnetic field changes direction. There is a way to determine which direction the magnetic flux goes in relation to the direction of current, but you won't be tested on this, so I will not cover it in any great detail. Here we see, so this is a voltage meter with, you can see 0 is in the center of the meter, and this is just a conductor. This is just a, call it a copper wire that's connected to the meter. There is no external voltage source connected to this wire. However, we have a magnet here with the north and the south pole, and what this arrow is showing is that the wire itself, the conductor itself, is physically moving inside of this magnetic field. In this case, it's moving down through the magnetic field, and this produces a voltage. It induces a voltage onto that conductor, and that is shown on our zero center meter here. It's giving a negative voltage. Now we have the same meter, the same wire, the same magnet. North is on the left, south is on the right, and now the conductor is moving up through the magnetic field. A voltage is induced onto the conductor, and now because we're moving the wire in the opposite direction, we're now getting a positive voltage. Here we have a very similar setup. Voltage meter, conductor, no external voltage, but now the magnet is switched around, so now the south pole is on the left and the north pole is on the right, the wire is moving down through the magnetic field again. Remember from a couple of slides ago, we got a negative voltage. Now we're getting a positive voltage because the magnet switched polarities. Here we have a little bit different setup. We still have the zero center voltage meter. We have a conductor, and this time the conductor is wrapped sort of around this coil several times. This coil is sort of hollow in the middle, and here we have a magnetic rod. North is on this end of the rod and south is on this end of the rod. And the magnet itself is physically moving through the center of the coil. And a voltage is induced onto the conductor. It happens to be a negative voltage because of the direction of movement. And it's actually a bigger voltage than what we saw in the earlier setup. And it's because of the coil of wire. There's literally more wire that is in the field, the magnetic field. And that brings us to three very important points here. You will be tested on this. So to determine the amount of induced voltage onto the wire is determined by three things, and you see it on the screen here. The number of turns of wire, basically the strength of the magnet, how strong it is, and then third, the speed of the cutting action. So how quickly is the conductor moving through the magnetic field? So these are the three things that determine the amount of induced voltage. This slide is showing basically two different generators. Both have the same setup, but this top one here has one single wire wrapped around it, versus this system down here has several loops of wire. And we can see here that the voltage induced on the single loop version is very small versus the voltage induced on the multi-loop version is much higher. So again, the number of turns of wire is one of the three things that determines the amount of induced voltage. And we see the more turns of wire, the more voltage. The fewer turns of wire, the less voltage. And here we have another setup. We've got a coil of wire, no external voltage is connected to it. We have some sort of a load here. And in this top version, the magnet is stationary. There's no movement. There's no cutting action. We saw earlier that the speed of the cutting action is one of the three factors. There's no cutting action. There's no movement. So there's no voltage or induced and no current is flowing. Versus down here, the magnet is moving from right to left through the coil. A voltage is induced onto the conductor, and now we have current flowing through the load. So to summarize this chapter, magnetic field is created around a conductor when current flows through it. Alternatively, voltage is induced in the conductor when the conductor is cut by a magnetic field. Again, it is possible to figure out the polarity of the induced voltage in relation to the direction of motion, but I won't cover it in any detail because you won't be tested on it. I just want you to understand the concept. And finally, this is something you will be tested on. The factors that determine the amount of voltage, three things: the number of turns of wire, the strength of the magnetic field, and the speed of the cutting action.